Okay, first we're just going to start with all the definitions that we need to know, and then we're just going to move on to practicing some of these problems, okay? So, before we talk about integration, let's kind of go back and talk about differentiation for a moment. So, let's talk about the differentiation of the natural log. So, what do you guys remember about the derivative of natural log? So, like if I have, what's the derivative in terms of x of the natural log of x? What is the derivative of the natural log of x? I'll talk about why that is there in just a second. 1 over x. It brings up a very good question. I'll talk about why I included the absolute value here in just a second, okay? But I hope that you remember that the derivative of natural log of x is 1 over x. However, you don't always have natural log of x. So what if it's something else? So let's pretend that we have the derivative of terms of u, of the natural log of u. What would that be? Good. The derivative of u over just u. It's basically what you did here. Think about it. What's the derivative of x? Well, it's 1 over x, right? So you need to find the derivative of whatever term you have and divide it by that term itself. That's basically what the rule was. But most of you guys just remember it for the parent function. But that's really what's happening there. Okay? Do we remember that? Okay. So now let's talk about integration. And that's where this whole absolute value is going to kind of come into play, and we'll talk about it here in just a second. So we have logarithmic rule for integration. Alright, we're going to let u be differentiable. Then the following is true. The antiderivative of 1 over x dx would be equal to the natural log of the absolute value of x plus c. Makes sense, right? Look at the rule for differentiation. Agreed? It's kind of going backwards, right? So it's, in this case, if I'm starting here and I anti-differentiate, I should get that. Agreed? Let's talk about this whole absolute value. Why can anybody care or kind of try to guess why I need that absolute value there? Why would there be an absolute value of the natural log? You cannot take the logarithm of a negative number. That is the reason why we need the absolute value there. You can input any negative value there, but the absolute value will then turn into a positive, and then you can take the logarithm of that. Agreed? Therefore, that is the reason why you need to have that absolute value there. We cannot take the logarithm of a negative number. Cool? Alright. If we can expand then this rule to any function, then what if you have something like this? The integral of 1 over u du. Then you would say that the antidifferentiate, or the integral of 1 over u du would be natural log absolute value of u plus c. Agreed? Now, one thing I kind of want to build upon that so that you can understand and connect it to this is that technically here, this du is equal to u prime dx. That's where this u prime over here from the differentiation rule kind of went, okay? So I can further, or maybe kind of further say that I can rewrite this instead of 1 over u. Are you guys okay? Maybe I can say u prime over u du, right? That'll be the same thing as what we get here, the natural log of the absolute value of u plus c. Okay? That's basically taking this rule number 1, the parent function, and applying it to a little bit more complicated natural log. Okay? And that's it. That's the notes. Now we're just going to practice some problems, and I'm going to kind of basically show you how this works. But before we do that, I'm going to need to introduce you to some more anti-differentiation rules that you don't know. Okay, so there's 6 more rules that you're going to have to memorize, unfortunately. My suggestion is, guys, now we're starting to really, we have a lot of rules now. Suggestions to you is, 1, if you're kind of like a note card person, then make some note cards so that you can memorize this. There's also some great tools online where you can kind of make your online note cards, and you can kind of play games with it where you're kind of memorizing things. Oh, gotcha. Cool. Sweet. No, that's borrowing. That's being smart. The other thing that I will do for you guys is I found this card that somebody uses down in, I think I'm saying this wrong, Logarithmic, Texas. Logarithmic, Texas. Sure. It's called Stuff You Must Know Cold for Calculus. That's just who created it. It's called. It's basically a note card with everything you need to have memorized by the end of this course in order to be successful for the AP exam. Stuff You Must Know Cold. Just look it up. Stuff You Must Know Cold for Calculus or something like that. I'll find it and I'll give you guys a copy of it. I'll print them out. I can either find an empty copy so you can fill it out on your own, or I can find one that's already filled out. Obviously, more right at this moment, you won't know half of the things that are on that card because we're not even halfway through the year. Okay, but anyways, here's more rules that you're gonna have to memorize. Ready? So we got some integration rules, and they have to do with trigonometry. Ready? Some of these you actually already know. So what is the integral of sine u du? That one you should know. So what's the integral of that? Negative cosine u plus some constant. Agreed? And therefore you should also know this one. What is the integral of cosine u du? Sine u plus c. Alright, those two, relatively, we've used them. You used them last class. You've used them for a few times. You've been tested over, actually. But then there's 4 more that you don't quite know. And then there's also others that I'm not going to talk about because you actually know them. For example, you should know that the antiderivative of secant squared is what? It's tangent, right? We've talked about those. So I'm going to just keep it to no powers. So now we're just going to keep going. Sine, cosine, what do you think now I'm going to ask? Tangent. Well, if you go back to your differentiation rules, there's none of those that gives you that the derivative of one of the trig functions is tangent, right? We have one that has with tangent and secant, right? But it's not just tangent by itself. So this is one that's going to be brand new to you. So the antiderivative of tangent of u in terms of u is as follows.
Wait, can I try to guess?
Sure.
Is it,
You have it on the computer. Negative natural log of the absolute value of cosine u plus c.
Wow.
Alright, so that one's brand new. Nothing you've seen before.
It also says
Or maybe.
say, ln absolute value secant x plus c.
Why? I'm sure it did. Let's just keep it as that one for our purposes. But sure, the internet is a wonderful tool. Alright, then, what is the integral of cotangent of u du? This one's also brand new to you. It's the natural log of...
I have a guess.
Yes, sir. The natural log of sine u plus c. Okay? The antiderivative of secant u du is going to be the natural log of the absolute value of secant u plus tangent u plus c. That almost looks similar,
Yeah, it's just plus secant.
right?
I have a question. Are we ever going to use, like, identities again? Yeah, okay. When?
Maybe in this section. Great question.
Because I was just wondering, like, we've done a lot of stuff, like, are we going to go over, like, everything in pre-calc, just, like, relating it to calculus?
Not everything, but a lot of things that we learned in pre-calc have already applied here. Hopefully you've recognized. Yes, like, I know we didn't spend a whole bunch of time in pre-calc with the whole composite functions, but look at how important they have been for calculus so far. Anyways, we're kind of deviating. One more. Cosecant of u du equals to the negative natural log of, you want to take a guess without using the computer? Or are they all present in there already?
No, there's only two. Natural log of, wait, hang on. It's going to be cosecant u. No, it's going to be cosecant. No, this is an actual, like, cosecant. Make up your mind. U minus cosecant.
Oh, close. That little minus is going to take care of it. So it's plus cotangent u plus c. Alright, so these are brand new to you, so memorize. Make some flashcards. I don't know, whatever's going to get you to memorize them. Okay? Alright. Ready? Let's get to it. Okay? I'm going to give you some steps to solving these problems, but I'm going to be honest, they're very just straightforward, obvious things that you need to do, but I can just go ahead and break it down into steps for differentiation. Alright. Step number one, in my opinion, would be to identify the type of integration rule. That's next class.
Okay.
Yep.
I was going to say, like, is that actually, like, something we need to know?
Yes. Identify the integration rule. U substitution. Power rule, any other rule that you can think of, but really, like, one of the new ones for you is basically the U substitution and the rules that you learned today, okay? Very straightforward. Number two, if substitution does not work, so if substitution is not enough and it doesn't work, then you can try the following. Using trig identities. Using division. When I mean that, I mean like synthetic division or long division. Okay? And last but not least, you can use any of the operations that you know since elementary school. Multiplication, division, addition, subtraction. Division's right here. Sorry, I just kind of went too high. Alright, so if substitution doesn't work, you're going to have to rely some of those pre-calc skills that you learned. Okay? Some identities, some division, like synthetic division, long division, if possible. Alright, let's do this. Example number one. The antiderivative of 3 over 3x minus 5 dx. Alright, when I look at that, hopefully you can recognize that this is a natural log. Why? What's the derivative of the denominator? 3. Oh, there it is, right? So this one maybe was as easy as for you to recognize, and you can go to the answer straight up. However, if you don't see that, you can use the whole concept of U substitution. You can let U be what in this case? What do you guys think? Well, remember how we're always taking the derivative of U? It would make more sense to let U be 3x minus 5. Agreed? Therefore, if you take the derivative of U in terms of x, du is equal to 3 dx. Agreed? Now, maybe now you can see the following. Then you would have 1 over 3x minus 5 times 3 dx, right? That's the same expression. Do you guys agree? Well, now you know and you can make some substitutions. This is the antiderivative of 1 over u, and 3 dx is the same thing as du. And now hopefully you can see that this is going to be equal to what? What is the antiderivative of 1 over u? Natural log of the absolute value of u plus c, which ultimately in our case is going to be the natural log of the absolute value of 3x minus 5 plus c. Make sure that you include those absolute value symbols, because is there any time that if you just look at that, could that be negative 3x minus 5? Yes, it could. So you need to make sure you include the absolute value in that case. Otherwise, you're not going to be able to take the logarithm of something that is negative. Okay? Easy? Cool. We got about 8 more examples. All right. Sample number 2. The antiderivative of 2x to the third power plus 3x over x to the fourth plus 3x squared dx. Okay. So we look at this thing, and again, I'm kind of recognizing something when I compare the numerator to the denominator. But it's not as straightforward as example number 1. Do you guys agree? Because the derivative of the denominator is going to be 4x to the third power plus 6x. Notice how the powers are matching, right? We're having this x squared, and then we're having this x to the third, and then we're having this x to the first power. But the constants in front of them are not matching. Agreed? Well, let's try U substitution and let's see where it takes us. Well, we're going to let u equals to x to the fourth plus 3x squared. Therefore, du would be 4x to the third plus 6x dx. Agreed? Well, what if I rewrite this expression as following? The integral of 1 over x to the fourth plus 3x squared times 2x to the third plus 3x dx. Do you guys agree how that would be the same thing as that? All I did was just... Well, why would I want to do that? Well, if I make substitutions as it stands right now, I would have 1 over u, agreed? And then I would have this, 2x to the third plus 3x dx. Well, when I look at here, it's not exactly the same, agreed? Any suggestions of how I can manipulate this expression to make it match exactly what I have here? Okay, so what if I say du equals to 2 times 2x to the third plus 3x dx? You guys with me? Now it looks very, very close, but now I have this 2 extra. What can I do with the 2? Because I only care about 2x to the third plus 3x dx, right? I need to make that substitution there. But that 2 is on the way. So what you can do is you can divide it out. What you do to one side, you do to the other. Okay? So then you would have du over 2 equals 2x to the third plus 3x dx. And you're ready to make the substitution. This is the exact same thing as that. Therefore, we can replace it with du over 2. Suggestions of now everything's in terms of u. What could I do before I anti-differentiate this thing? Take out a 1/2. So if I take out the 1/2, this becomes 1 over u du. Did I lose anyone with y? That would be a 1/2. Right? It will be like this is the same thing as saying 1/2 du, right? Okay, so now you're ready to anti-differentiate this. 1/2 times, what's the derivative of 1 over u? I mean the antiderivative, I'm sorry. Natural log of the absolute value of u plus c. Agreed? So now all you got to do is go back and make your substitutions. 1/2 times the natural log of, well, what's the absolute value in this case of u? So we have x to the 4th plus 3x squared plus c. I have a question for you guys. Are the absolute value symbols in here absolutely required for this specific problem? Why not? Can the x to the 4 plus 3x squared ever be negative? So this would be one of those rare scenarios where you could actually just write it like this and you would be okay. They will not take points off if you leave the absolute value symbols in there, but I just kind of wanted to share that with you. Sometimes you're able to drop them because that expression would never be negative. Okay? How? It would be 0. Oh, the log of 0? Yeah, but even with the absolute value, there's nothing we can do that, right? Like the absolute value of 0 will still be 0. But yeah, you have a point there. Okay? Alright, questions so far. Are we good? You still be undefined. That means you have an asymptote. You remember your parent functions? Okay, cool. Just making sure. Alright. Questions so far? We're good with this problem? Example number 3. The antiderivative of 3x over the square root of 16 minus x squared dx. Uh-oh. Alright, they're starting to get a little bit more complicated now. Suggestions? You gotta what? What do you mean move everything? Okay, so then you want to do this? That? Is that what you meant? Okay, sure, we can do that. Then what? There's one thing I suggest you don't have to, but I suggest you can. Take out the constant. Make your life easier. So 3 antiderivative of 16 minus x squared to the negative 1/2 x dx. Okay, from here, what do you guys suggest I do? U sub. So let u equal to what in this case? (16 minus x squared). Therefore, the derivative of u in terms of x would be what, guys? Negative 2x dx, right? Okay, do we have enough to make substitutions here? Yes, but we have to manipulate this a little bit, right? I don't want this negative 2, so what do you suggest I do? Awesome. So then this becomes negative du over 2 equals to x dx, right? Do I have enough to make a substitution now? We sure do. So now we have 3 antiderivative of u to the negative 1/2. X dx is negative du over 2, right? And before you go further, I suggest that you take out that constant once again. So then this becomes 3 times negative 1/2, right? Antiderivative of u to the negative 1/2 du. So then this becomes negative 3/2 times, what's the antiderivative of u to the negative 1/2?
So
2u 1/2 plus c. Agreed? Therefore, the answer to this would be, well, what's going to happen when you do negative 3/2 times 2? The 2's are going to cancel out, leaving you with negative 3. U in your case was 16 minus x squared to the 1/2. So what if I write it like this? Square root of 16 minus x squared, right? Plus c. So negative 3 times the square root of 16 minus x squared plus c. So this one didn't even require natural log, right? We're good? Alright. Next example. 1 over 2x times the natural log of x to the 4th power dx. We have the antiderivative of 1 over 2x times natural log of x to the 4th power dx. Okay. This one gotten a lot more challenging than everything we've done. Agreed? This one's a lot harder to see what to do here. When you get stuck and you're not really sure what to do, I suggest that you try to use U substitution of some sort. The question that I get a lot is like, well, where would I know what U is? Well, before you determine what that is, I suggest that you take out any constants that you can. So in this case, you should be able to recognize that you can take out a 1/2. So then you have 1/2 over, times the antiderivative of 1 over x natural log of x to the 4th dx. Okay? Now, my suggestion from here is that you make u be the more complicated part that you see here, which in my case would be u would be natural log of x to the 4th power. Now, I want you to go back to pre-calc for a moment. There's another way that you can rewrite natural log of x to the 4th power. What would that be? The power rule of logarithms, remember that allows you to bring the power to the front and say that that's the same thing as u equals to 4 ln x, right? Well, why would I want to do that? Because it would make differentiation a lot easier, right? What is the derivative of u in terms of x? Of 4 natural log x. Well, this becomes a product rule, right? 4 times, what's the derivative of natural log of x? 1 over x, plus ln x times the derivative of 4, which will be 0, right? So anything times 0 is just going to go away, so that's kind of pointless, right? So then we can say that du dx is equal to 4 over x. Therefore, du equals to 4 over x dx. Agreed? Okay, this one, I'm like, okay, what if I start making substitution to know what I gotta do? Well, I know that ln x to the 4th is u, so I'm gonna say this becomes 1 over u. But I still have that x and that dx, right? Are you guys okay with me saying that maybe I can take this and multiply it to 1 over x dx? You guys okay with that? Alright, then I'm like, wait a second, well this part right here looks very, very similar to that part right there, with the exception that I have that 4 there. right? What can I do to this expression to manipulate it so that it looks exactly as 1 over x dx? Divide by both sides by 4. So then you would say that du over 4 equals to 1 over x dx. Agreed? Now this looks exactly like that, and we can make the substitution. 1/2 times the integral of 1 over u times du over 4. You have another constant, so take that out of the integral. So 1/2 times 1/4 times the antiderivative of 1 over u du. That took a lot of steps, a lot of manipulations, so that we can finally get to the calculus part of it. Agreed? Because we haven't really done any calculus if you think about it. All we've done has been prepare this problem so that we can actually do the calculus on it. So this becomes 1/8 times, well, what's the antiderivative of 1 over u? Natural log of the absolute value of u plus c. So what would your final answer be? One-eighth of the natural log of the absolute value. Well, what was u in our case? 4 natural log of x plus c. Alright, one more example, guys, for today. The antiderivative of square root of x over square root of x plus 2 dx. Alright, what do you guys suggest I do in this problem? We could. I'm going to be honest with you. I think it's going to make the problem more complicated if we try to do that this time. Okay, so let's do this. Let's think of U substitution. Let U equal to what? Let's make this the more complicated side. So how about square root of x plus 2? Let's see what happens, okay? Well, if I take the derivative of this, what's the derivative of u in terms of x? Well, what's the derivative of square root of x? Well, that's the same thing as x to the 1/2, so 1/2 times x to the negative 1/2, right? You guys with me? So then, are you guys okay with me saying that that's the same thing as 1 over 2 root x? And what's the derivative of 2? Well, it's 0, so then that dx. Agreed? You guys with me? Okay. Well, does that look like it's going to help me much? Because as it stands, here's what I have. Okay, you don't have to write this down, but here's what I have so far. I have square root of x over u dx, right? There's no way for me to substitute square root of x, or is there? Well, then you're trying to tell me to then do here that that's square root of x is the same thing as u minus 2. Okay, so then I would have u minus 2 over u dx, right? Okay, but then how am I going to, I need to know what dx is. What can I do? So, I'm sorry, so I have du equals 1 to root x dx, right? You guys with me? How can I get that dx by itself? Well, I'm going to do what Saf said, and I'm going to multiply both sides times 2 root x. You guys with me? So therefore you have the antiderivative of u minus 2 over u, 2 root x du. Okay, then what? Because we have a problem here. We still have x. Do you guys agree with me? So we can't do anything until we find a way to get rid of that square root x. Two times u minus 2. So, okay. Alright, so now let me make sure we all understand what he's telling us to do. I have this root x, and he's like, well, root x is the same thing as u minus 2. Okay, so let's see what happens. Times 2 times u minus 2 du. Right? Alright. This is starting to get algebra nasty. Agreed? So what if I rewrite this? I don't like that 2. Can I take it out? Right? So then what if I have u minus 2 times u minus 2 over u du. You guys agree? Okay. 2 integral of, this is the same thing as u minus 2 squared, right? I still don't see much happening, so I'm going to kind of just expand this and hope that I can differentiate from there, right? If I expand this, this becomes u squared minus 4u plus 4 all over u du. Agreed? And from here I'm actually kind of relieved, because now I can break this into 3 different integrants. Agreed? 2 times the integral of u squared over u du minus the integral of 4u over u du plus the integral of 4 over u du. Agreed? Okay. Then you have 2 times, well, what's u squared over u? U. So the integral of u du minus 4u over u is the integral of 4 du plus, well, that's not going to change, so it's 4 over u du, right? Alright, so 2 times, what's the antiderivative of u? One half u squared minus, what's the antiderivative of 4? 4u plus, are you guys okay with me pulling this 4 out? So 4 times, if I pull out the 4, then that means that this becomes a 4, and this stays as 1, right? Agreed? So what's the antiderivative of 1 over u? Natural log of the absolute value of u plus c. Right? That times that is going to cancel out. So u squared minus 8u plus 8 ln absolute value of u plus c. Right? Gross. We're done, but now you just got to go back in what was u. Square root of x plus 2, right? So then this becomes square root of x plus 2 squared minus 8 times square root of x plus 2 plus 8 natural log of square root of x plus 2 plus c. Right? Now, I'm going to be honest with you. If you get a problem like this on the AP exam, it's going to be a multiple choice, and I guarantee you that the answer is not going to be this one. You're going to have to simplify this thing out, because you have this squared, right? Alright, so this is, like I said, this will be the last problem we're doing today, but what's this square? Well, square root of x times square root of x is x. 2 times square root of x is 2 square root of x, plus another 2, that'll be plus 4, minus 8 root x, minus 16, plus 8 natural log of the absolute value square root of x, plus 2, plus c. That's with me? And again, that will not be your final answer because you got to now combine like terms. I have 4 root x, and then I have negative 8 root x. I have x, I don't have any other x's, right? So this is going to become, I'm going to kind of come up here, sorry. X minus 4 root x plus 8 natural log of square root of x plus 2, right? That takes care of that. But I have 4 minus 16, right? Which is negative 12, right? And then you have another constant, agreed? So when you combine that, you're just going to have another constant. You do not need to include the negative 12. Because when you add or subtract whatever this constant is, it's just going to be another constant. Understood? Alright, that's where we're going to stop for today. So for tonight's homework, you only have that 5.5 homework. We'll finish 5.7 at the beginning of class next time, and I'll give you some time for homework during class as well for this. Cool? Alright, that's all I got for you.